So problem 27 from section 4.4 has to do with tour, and we want to maximize profit. So let's remember what profit is. Profit is what's left over after we take revenue and we subtract off cost. So far so good? So this has got a particularly strange revenue and cost structure. Okay, the revenue is $200 per person if there's exactly 50. But for every additional person over 50, then the cost per person goes down by $2. So it's $200 minus $2 for every person above 50. Now that's how much it costs per person. If it was exactly 50, 50 minus 50 is exactly $200 per person. If there was 51 people, 51 minus 50 is 1. It would be 200 minus 2, $198 per person. The total revenue is going to be the per person cost multiplied by the number of people. So there's your revenue. The cost of the tour, we say it's a flat rate of there's $6,000 in fixed costs. But for every person that's on the tour, it costs an additional $32. Right? So we got revenue and we have costs. So we end up with a profit that's equal to, I might try to clean this up a little bit, 200 minus 2x plus 100 times x. So there's our revenue. And then let's subtract off our costs. 6,000 plus 32x. So revenues minus costs. I think we can clean this up just a little bit more. 300 minus 2x times x minus 6,000 and minus 32x. I think I can clean it up a little bit more. I want to clean it up before I have to do the derivative. How about 300x minus 2x squared minus 6,000 minus 32x? How about negative 2x squared plus 268x? Is that all right? Yeah. Minus 6,000. Again, and that's my profit. But what I want to do is I want to maximize profit. I would like to know for what value x do I get the biggest profit. And whenever we try to optimize something, we want to look at the derivative, set it equal to 0, and see if there's a local maximum or minimum that we can use. So what is the derivative here? We get negative 4x plus 268. What happens when we set that equal to 0? $268 is equal to 4x. Let's divide both sides by 4, and we get x is equal to 67. I'm going to do a quick check here. If I put a number line with P prime, and I put the number 67, and if I got really, really big numbers for x, I think that those values would be negative. If I take numbers that are really, really small over here, I think P prime ends up being positive, which means the profit is increasing, reaches a maximum at 68, and then it decreases after. Sorry, a maximum of 67, and then decreases afterwards. So 67 people is the number that will maximize our profit. How's that?
That makes sense.
All right. The tricky part, by the way, in this problem is right there.
Yeah.
I stared at this problem for a long time and did not get that.
Because like I get how to do the rest of this, I just like cannot get the.
She's
starting
leaning toward
equation.
HP.
Okay.
What would you think?
HP's good. I mean, my discussion with her is, what are you going to use this for?
Crap.
HP is just fine for that then.
Okay.
All right. All right. Let's
Just